in the world of high-tech manufacturing, there's this hidden battle going on every single second. It's a fight for absolute perfection, where even the tiniest, most microscopic mistake can have massive consequences. Today, we're going to take you right inside that battle.
So let me ask you this. What could a tiny little scratch and a massive million-dollar recall possibly have in common? I know, it sounds like a trick question, right? One's just a cosmetic flaw, the other, well, it's a total corporate disaster. But what if I told you they actually start in the exact same place?
Yup. They both kick off with a single process failure. You see, every huge recall, every scary safety issue, it all begins with something small, a machine that's just slightly out of alignment, a tiny imperfection in the material. And that's it. That's the starting point, and that's exactly why manufacturers are so obsessed with controlling their processes.
So how do you prevent these failures from ever happening? For years, the industry has leaned on this incredibly powerful framework called Six Sigma. And right at the heart of it is a document that's basically the ultimate rulebook for quality.
It's called a control plan, and you can think of it like the DNA for a manufacturing process. It spells out every single check, every measurement, and every standard that a product has to hit. It's all about ensuring that the millionth part coming off the line is absolutely identical to the very first one. Now, what's so cool is that this plan isn't just a one-and-done thing. It actually grows up with the product. When you're just making a few prototypes, the inspection is super intense, like checking every single thing. Then, as you scale up for pre-launch, it adapts. And finally, for mass production, it becomes this super streamlined, comprehensive guide. And this part is absolutely crucial. A control plan can't just sit on a shelf and collect dust. It has to be a living, breathing document. If you change a tool, switch a material, or tweak the process, that plan has to be updated right away. It's got to mirror what's actually happening on the factory floor in real time.
Okay, but let's be realistic. Even with the best plans in the world, things can still go wrong. A process can drift off course. So, what happens then? Well, that's when the emergency protocol kicks in.
This is the moment you stop hoping for the best and start planning for the worst. It's called a reaction plan, and it's your step-by-step playbook for what to do the second an error pops up. It takes all the panic and guesswork right out of the equation.
And what's so smart about this is the escalating response. See, it doesn't always mean you just slam on the big red emergency stop button. No, it starts small with just closer monitoring. If the problem keeps going, maybe you try a manual override. The actions get more and more serious until you get to a full process stop, but only if it's absolutely necessary. It's a really intelligent, tiered defense system.
All right, so we've got the classic playbook down. Now, this is where things get really cool. Let's see how all these foundational ideas are being put on steroids by a new wave of technology. We're talking about a complete revolution in how we see, measure, and control quality.
So meet the new quality inspector. And no, this isn't science fiction. This is a collaborative robot, a Cobot, and it's armed with a super high-resolution vision system. It's designed to inspect incredibly complex car parts over and over again without ever getting tired and with a level of precision that's, well, superhuman. So why is this such a game changer? Well, think about it. Traditional human inspection is important, for sure, but it has its limits. It's slow, it's expensive, and honestly, after you've stared at 1,000 identical parts, even the sharpest inspector can get fatigued and miss something. Automation is all about consistency. But here's the catch. Even a super smart AI isn't perfect right out of the box. A single AI model can get things wrong. It might flag a perfectly good part as being defective. We call that a false positive. Or even worse, it could miss a real defect, a false negative. And in manufacturing, both of those mistakes cost a lot of money. So how do you make the AI even smarter? You use a brilliant technique called Ensemble Learning. Instead of just relying on one AI brain, you use two specialized AIs and basically have them check each other's work. It's kind of like getting a second opinion from a specialist. Because each AI is trained to look for defects in a slightly different way, they only flag a problem if they both agree it's a defect. This filters out all the noise and makes the system way, way more accurate. And hey, the data speaks for itself. Just look at this. On their own, the first model had 8 false positives, and the second one had 16. But when you combine them using this ensemble method, that number plummets down to just 2. That's not just a small improvement, that's an incredible leap in reliability.
So let's walk through the whole automated workflow from start to finish. First, the Cobots cameras scan the part, grabbing a super detailed image. Instantly, the AI duo gets to work, hunting for any potential defects. If they find something, it's not over. The system then moves to the next critical stage, measuring just how big the problem actually is.
And here it is, the final verdict. The system doesn't just find a flaw, it measures its exact size, right down to the millimeter. Then, it compares that measurement against a preset rule, like, say, anything over 2 millimeters is an automatic failure. And it makes the final call, accept or reject. There's no ambiguity, no maybe, just cold, hard data.
Okay, so let's zoom out for a second. What does all of this mean when we put it together? What we're seeing is this incredible fusion of timeless, old-school principles and absolutely groundbreaking new technology. The fundamental goal? It hasn't changed one bit. Whether you're using a pen and a paper checklist or an AI-powered robot, you are still just trying to control a process to guarantee quality. The why has always been the same, but the how, well, the how is evolving faster than we've ever seen before. So if you take anything away from this, let it be these 4 things. First, control plans are the absolute bedrock of quality. Second, reaction plans are that critical safety net you can't live without. Third, AI and robotics, they're bringing speed and consistency to a whole new level. And finally, remember that clever techniques like Ensemble Learning are what make these new tools truly trustworthy.
And all of this leads to one last, really fascinating question to chew on. As our factories get smarter and more autonomous, the very nature of control is changing. The question isn't just how we control quality anymore, it's who, or maybe even what, will be designing those controls for us in the future.